Let's do this. Four x1 plus 5x2 equals 29. So I can turn this into a matrix. 7, 4, 3, 5. Okay, which is a 2 by 2. Yes? To multiply, I need a 2 by 1, right? So 2 rows, and those 2 rows are x1 and x2. And I can do the math because it's a 2 by 2, and they're going to end up, the net result is going to be a 2 by 1, which is 45 and 29. Okay, everybody get that? That's how we want to solve this. This is an equation now. It's an equation. It's easier. It's much, 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 much easier looking, and one can assume that there's some way we can take this, okay? Some way we can take this now and solve it for x1 and x2 without having to do all the wacky algebra that we do, right? Somehow, we haven't done division yet, and you really can't divide matrices. You have to do something else. But really what we're trying to do is get x1. What we want to do is just get x1 and x2 on its side, get this over here somehow, right? Just basic algebra, get this over here somehow. And in doing so, we can then solve it for x1 and x2. Really easily, really easily. All right? Now, usually we write this out this way. We say AX equals D. And you're saying, wait. A is a matrix, X is a matrix, and D is a matrix. And in a book or somewhere, usually you'd see those in bold, right? They'd print it out in a bold letter, and the bold letter would tell you it's a matrix. But I have A, I have X, I have D. A is full of numbers, D is full of numbers. I need to solve for X. If I can just get the A over here somehow, I can play with those numbers and solve for x1 and x2. Yes? Yes. Okay? This is why matrices are so cool. I can take this A, X, and D. I can find X. I can find those values of X without doing all the wiki algebra. And you're saying, well, it's not really that hard to do all that algebra. Well, imagine I gave you 6 equations with 6 variables in it. And now you're going to try to put this into that and sub that into that. Forget that. If I give you 6 variables, poof, he said, poof, it still looks like this. It doesn't matter how many x's I have. Okay? Does not matter how many equations I have or how many x's I have. If this is a 10 by, right? 10 by 10, and this is a 10 by 1, and this is a 10 by 1, I can solve that using the same technique that I would use to solve if it's a 2. So it simplifies your algebra tremendously, and also simplifies you writing it down, because I can write AX equals D, and that could be a 1,000 equation econometric model. Or it could be a 2 equation model. It could be this, right? This thing that we have, I could have that. I could. But this could be 1,000 by 1,000, and 1,000 by 1, and 1,000 by 1. Right? It doesn't matter how many rows and columns I have. I can write it out as AX equals D. That makes our lives really simple. This is a very simple way to write things out, and we can look at it and know what math has to be done to solve the problem really simply, just by looking at it, right? We're just looking at it. Is everybody with me on this? We're just looking at it, and we can see what has to happen. Yes? No? Okay. Remember y equals c plus I plus g, and c equals a plus by. Yes? Well, I have two variables in this. I have c and I have y. Yes? And then what are my coefficients? Well, y and c. Yes? Y and y. Y. Y has, yes, 1. Yeah? And it's got a b, but the b is on the wrong side. So it's going to have a minus b and a minus 1 and a 1. And you're like, wait, you sure about that? And I'm like, yes, I am. Okay? Because you're going to plug the c into the y, you're going to get a minus. Yeah. No? Yeah. Row times column. All right? Y minus c equals I plus g. Yes? Yes? Row versus column. 1 times y minus 1 times c equals I plus g. Oh, y minus c equals I plus g. We see that? It's beautiful. Yeah. Or we can take this equation and go c minus by equals a. Can we do that? Just algebra, right? Move this over to here. C minus by equals a. So I can take row times column. Yes? Row times column. And I get minus by plus c, 1 times c, equals a. All I have to do is put the constants on one side and the variables on the other. Now, this should be minus c plus y kind of deal. Actually, yeah, you know what I mean. So really, right? No? You have y minus c equals I plus g, and you have minus by plus c equals a. That's a matrix, a vector. And now I have 1 minus 1 minus b, 1, 1 minus 1 minus b, and 1. Okay? And I have y and c, 2 by 2, 2 by 1, 2 by 1. Now I can solve that, which can get messy equation-wise, and I can solve it just by doing my matrices, right? I have ax equals d still. Okay, and I could solve that. Is that exciting? Yeah, and then I could add taxes into it or other things into it, and I still can write it out as ax equals d, right? And I can do all of these so exciting manipulations. Okay? So exciting manipulations that I can do. Yes? Okay. Now it turns out we can't do division. Okay? We can't do division in matrices. We can do something called inversion, though. And you're saying, eh? So in regular numbers, right, 4 divided by 2 is equal to 4 times a half. Yes? Yes? Divided by the 2 is the same as multiplying times a half. Either way, it's 4 over 2, which is 2. Okay? So we can't do this with matrices, but we can make this thing. We can make that thing. And how do I know I can make that? Well, how do I know that 1 over 2 works there? Well, if I take this 2 over here and I multiply it times the 1 over 2, what do I get? I get 1. In matrices, I have this thing which is equal to I. It's this identity matrix. Okay? And so A times this inverse of A, and we write it this way, A to the minus 1, because that's what this is, right? 1/2 is 2 to the minus 1. Yes? 1/2 equals 2 to the minus 1. Yeah? So this equation is 2 to the minus 1 times 2 to the plus 1. Yeah? Is 2 to the 0 power, which is 1. Okay? A times this A inverse thing is going to be equal to the identity matrix, which is 1. Okay? So we know what A is. We know what this is going to look like. We just have to find the matrix that multiplied times this matrix will give us an identity matrix. Right? So I have a matrix, let's go back here, 7, 3, 4, 5. Right? So I have this matrix which is 7, 3, 4, and 5. If that's A, I need to multiply it times something which will give me I, right? And I would be 1, 1, 0, 0. 2 by 2, 2 by 2, 2 by 2. What is that matrix? I need to figure that out. Yes? I really, really, really need to figure that out. I do. Trust me. Okay? Really, really, really need to figure that out. Let me just say. Okay? And I'm not asking you to do that. We're going to do that in a later, actually in the next video.